Hey there, Matt here, and this is my Arduino Compatible FPGA board. And now that the boards are back and available for purchase, I thought it would be important to take some time to explain the various aspects of the design and help you in getting your head around just what the board includes. So, to begin, at the center of the design is a Spartan 6 FPGA. This is a 144-pin TQFP, commercial version, and its speed grade is 2. And all this detail will be important later when creating new projects using the board along with the Xilinx tools. Now, first things first, taking a look at the board is the power supply. The board can be powered really three ways. The first would be to use the Arduino, and if you're plugging this into the Arduino, board to board, like other shields, you'll need to set this two-way jumper to the leftmost position. If you intend to use the DC jack, keep in mind that this requires a minimum of 6.7 volts input and can range as high as 15 volts max. The connector is center positive. To use this, you'll need to set the power jumper to this position, and whenever power is applied, the power LED will light up red. And if you simply have a 5-volt supply, maybe a hacked up USB cable, you can always run a flying lead to the centermost pin of that two-way jumper, being sure that ground is also connected on the board. You'll notice that around the board are a series of power headers, 2 3.3 volt, 1 5 volt, and 2 ground, each with 2 pins to give plenty of points to access power from the board or to hang a scope probe or something like that. Around the perimeter of the board are the various I/O pins, and you can connect these using flying leads or board to board using Arduino style headers found in the box. The board also includes a 4-way dipswitch and 4 red LEDs, and you can use these to test applications. To preserve the I/O from the dipswitch, it's connected to the FPGA only when jumpers are placed across these bottom 2 rows of pins. The LEDs are wired into these 4 pins located here and will work without jumpers. The big red button is optional and doesn't come really kitted out with any preset functions. However, it is wired into the FPGA and you can use it to control applications. Here you'll find your standard JTAG programming header, and directly adjacent are your voltage reference and another ground pin. This is where a Xilinx compatible JTAG programmer would be connected when you are building applications. This top row here is really designed for use with Altium Designer's specialized soft JTAG system. That's a part of their whole design and debug workflow. Off to the right here are the Spi Flash and an SPI multiplexer, along with some important jumpers for programming the device via Flash. To program the Flash from the Arduino, you need to use the ICSP header on the board. This jumper controls the routing of the FPGA's done signal back to the Arduino. If jumped, the done signal will be routed back to the Arduino, indicating the FPGA has completed its programming sequence. If you're not using a Flash programming flow, then this pin can be used as GPIO back to the Arduino. And lastly, this jumper controls which pin, either D9 or D10, on the Arduino to use for SPI chip select. Important to mention, the FPGA only supports 3.3 volts, so the board includes level shifters to interface the Arduino's higher 5-volt pins to the FPGA safely. Please check the schematic to see which pins are connected to the FPGA, and avoid connecting any pin that isn't first using a level shifter into the FPGA directly, as you'll destroy the device. I'll post constraint files shortly for this design, and I've already uploaded my first blinking LED example to my repository on GitHub. Enjoy, and ping me with questions as required.